Let's take a look at some examples for how this factoring stuff works. And again, we're factoring trinomials of the form ax squared plus bx plus c, so quadratic trinomials. Let's start with this one, 24x squared plus 20x minus 100. And if you look at 24 breaks down into a lot of different factors, and so does 100. There are quite a few of those. So the first thing to always remember is to always try and factor stuff out. We look for the greatest common factor among 24x squared, 20x, and negative 100. And we notice that we can pull a 4 out of each of those. So if I pull a 4 out, what I get is 6x squared plus 5x minus 25. I can check to make sure that this is right by, again, distributing this 4 to everything on the inside, and I do in fact get 24x squared plus 20x minus 100. Now this is a lot easier. 6 has a lot fewer factors than 24 does, and negative 25 has a lot fewer factors than 100 does. So my next step is to look at AC, and this 4 is just going to be along for the ride. I don't really have to think about it, but I can't forget about it. I don't have to think about it as I'm carrying it through. He's just going to stay on the outside. So I've kicked it outside. I don't have to think about it. He's still outside until I decide to bring him back in. So what I'm going to do is I'm going to excuse me. I'm going to find AC. So AC, that's 6 times negative 25, or negative 150. So I'm looking for two numbers that will give me negative 150 when I multiply them, but when I add them will give me 5. And whenever we do one of these examples, it's a really good idea to look at the original problem, pause the video, and see if you can figure it out on your own. From this point, check to see whether or not you can figure out what the two factors are that will give you 5 when you add them. The two factors that I'm looking for are 15 and negative 10. So these are the two factors that are going to bring me home. I have this 4 on the outside. I have 6x squared still. This ax squared and this c are not going to change throughout my entire problem. And I'm going to add 15x, subtract 10x, and subtract 25. Now I'm going to view this as one unit, and I'm going to see what I can factor out. I can factor out a 3 from 6 and 15, and I can factor out an x from both x squared and x. So my GCF is 3x. And I can't forget about this 4 on the outside. Now what's left over? I've got 6x squared. To get from 3x to 6x squared, I would have to multiply by 2x. If I multiply these two, that gives me 6x squared. And this will be plus 5. If I take 3x times 5, I'll get a 15x. Now I'm going to view these guys as a unit and see what I can factor out. I know that I'm supposed to end up with 2x plus 5, so why not write it? Why not make it a little bit easier on myself? And if I know it's supposed to be there, I'm just going to write it in and then figure out what's left over. So what do I need to multiply 2x by to get negative 10x? Well, 2 times 5 is 10, but I need it to be negative. And let's just verify, negative 5 times positive 5 is a negative 25. So this gives me exactly what I want. Again, this 4 is going to stay on the outside. I've got 3 times blue thing, and I've got negative 5 times blue thing. If I've got 3 x's of these, and I have negative 5 of these, I can just add those coefficients together. I can take this 3x, and then I can subtract 5, and then I can multiply that quantity times 2x plus 5. And I should have done that in blue, but it doesn't really matter. I don't really need these parentheses either, so I'm going to take them off. I get 3x minus 5 times 2x plus 5, and I've got this 4 hanging out on the outside. This is my factored form. The last thing I should do is I should distribute everything. I should foil this back out. Now my video's running. My video, I only have a certain amount of time on it, so I'm going to go kind of quick. So 12x minus 20, multiplying that by 2x plus 5, and then I take 12x times 2, I get 24x, 2x, so x squared. 24 times 5, or sorry, 12 times 5 is 60, so plus 60x minus 40x minus 100, and altogether that gives me what I started out with, 24x squared plus 20x minus 100. So that checks out. And when I do my check, I can't forget that that was just a check and not the actual factored form. The actual factored form is up higher. So I want to circle this or rewrite it down below to make sure that my grader knows what I know my final answer is. Okay, so that's one example. Let's do another example. Let's do 27 x to the third power minus 48 x. Now this looks a little different from what we've been doing because of a couple reasons. One, I've got this x right here. But I noticed that I can factor stuff out. So the first step before I do anything else is I'm going to factor stuff out. My GCF is 3x. So if I factor out my GCF, I get 3x times the quantity 9x squared minus 16. Alright, that looks a little bit cleaner. This looks like a quadratic, but I don't actually have a trinomial here, so that's a problem. But that's okay, because I can turn this into a trinomial. 9x squared plus, I don't have any x's, so I have 0 x's. This is an optional thing I can write, but it sometimes reduces the number of mistakes that I make. I'm going to write it in there. Usually when I'm actually doing it, I will not write in the 0x because I know a shortcut to it, and I'll share that in just a moment. Okay, we've got 3x times this quantity right here. Again, we're going to take a times c. So a times c is going to be 9 times negative 16. That will give me a negative 144. I'm looking for two things that multiply to give me negative 144 and add together to give me 0. Those things are going to have to be the same thing with an opposite sign. So if I take square root of this guy, I get 12. So my two numbers are 12 and negative 12. So again, my two numbers that multiply to give me 144 are negative 12 and positive 12. And these two guys add up to 0 because they are opposites of each other. They're additive inverses. Okay. I've got this 3x on the outside. I've got 9x squared still, but now I have plus 12x and minus 12x. These guys will add up to give me this 0x right here, and I don't need to write them, so it gives me exactly what I started with. And then I have a minus 16. I can't forget about that. Got to keep this 3x, and now I'm going to take this these guys, and I'm thinking of these as one unit. So this binomial, if I factor something out, if I factor out the GCF, I get a 3x. And now what I have left over is I have 3x plus 4. And then I know that I'm supposed to have another 3x plus 4. And I have to figure out what goes in this area right here. So I'm supposed to have something that when I multiply it by 3x, I get a negative 12x. Well, 3 times 4 is 12, and this is supposed to be a negative number. And if I check it, negative 4 times positive 4 will give me a negative 16. It works out exactly the way it's supposed to. This gives me 3x times 3x minus 4. All of that is in one set of parentheses, and in the other set I have 3x plus 4. And again, I don't need those parentheses. 3x times 3x minus 4. Need this set, but not this outside set. And 3x plus 4. This is my fully factored form. If I expand it out, I do my check, and this will give me, if I take 3x, let's do this multiplication first. That'll give me 9x squared minus 12x plus 12x, or if we do it the other way, we would get 12x minus 12x, doesn't matter, minus 16, and we get 3x times 9x squared minus 16. If I redistribute that, I get 27x to the third power minus 48x. Okay, and I can't forget that I need to make sure I know what my answer is, and make sure that my grader knows what my answer is, 3x plus 4. Okay, so this is my final answer. I could have also just circled it up here. This is just my check. And I do see that I in fact did end up with the same thing I started with. Oops, where was it? Yeah, right there. Okay. Okay, final example. Let's do this in 3 minutes. If we start with 4x squared plus 33x minus 70, I don't have any common factors among these things. My GCF is 1, so I can't really factor anything out. I'm going to take AC. AC is negative 280. I'm looking for two numbers that multiply together to give me 280 and add together to give me a positive 33. If you hunt for a little bit, you'll see that those numbers are 40 and negative 7. So I'm going to write 4x times, 4x, what am I doing? 4x squared plus 40x minus 7x minus 70. And then I factor out, this is 4x. Again, I'm looking at this guy right here. 4x, and inside the parentheses I get an x plus 10, and then I have an x plus 10 over here, x plus 10, and I need to figure out what I'm multiplying that by to give me this guy right here. So let's see, what do I multiply x by to get negative 7x? Oh, negative 7, that's easy. Negative 7 times 10 is negative 70. And if I add these together, 4x and negative 7, I can multiply that by x plus 10, and that should be my factored form. So let's do a quick check. 4x squared plus 40x minus 7x minus 70. If I combine like terms, 4x squared plus 33x minus 70. And this checks out, so my factored form is 4x minus 7 times x plus 10.